my name is Bruce Piggott of Brunner Systems, and I have been making a product called microlights for a few years now. I have made hundreds and hundreds of them, and I don't want to make any more of them again. They are very labour intensive, they take forever to make, and I don't make a great deal of money out of them. So basically I want to show you how you can make them yourself, and don't bother me again to make any microlights. Right, to make microlights you will need bright white surface mount LEDs. You can get them in different sizes. These are 0.8 by 1.8 millimeters in size, very difficult to solder. They were never intended to have wires soldered to them. You will need some enamel wire, self-tinning. I choose 36 standard wire gauge, and that's about right for the size of the LED. You will need a battery to test them. This is a PP3 9-volt battery with a 270 ohm resistor in series with it, which is correct for driving a white LED at about 20 milliamps. Make sure that you have a red wire on the positive and a black wire on the negative. On a PP3 battery, the smaller of the two connections is positive. This is for testing the LEDs and determining the polarity. You'll need some cardboard to mount them on because they're very delicate. I use black card with 2 notches, and I'll show you how they're wrapped round. They end up wrapped round like that. You will need a fine tipped soldering iron, some fine multi-core solder, small pair of tweezers, some double-sided adhesive tape, and probably most important of all, the strongest pair of reading glasses that you can bear to wear. These are about 5s, and with these I can see atoms, and you will need these. Right, apart from normal tools, scissors and pliers and cutters, we're ready to go. So, to make microlights, I recommend you invest in one of these, a double crocodile clip holder, which allows you to hold the wires and the microlight, keeps it in position when you're soldering it and working on it. Also, I've made the tiniest vise I've ever made. It consists of a croc clip connected, bolted to a piece of metal, and at the end of the crocodile clip a tiny strip of thin bronze which holds the surface mount LED in position while you're working on it. So, the microlights come in a strip like this. These strips are designed to go onto automatic robotic placement machines for surface mount. We have to peel back the plastic very carefully until a microlight drops out. That is a surface mount LED. You probably can't see it, and you put it under the tiny vise. Make sure that the white LED is uppermost. You can tell because there's some printing on the back, and there's 2 gold contacts either side, and to these you have to tin them ready to accept the wire, keeping the iron very clean. Touch a small drop of solder onto each end until you can see that the gold is now tinned. Now cut off a length of 36 standard wire gauge enamel covered wire I choose to use 1/2 metre. You may choose your own length. Holding the wire at each end, bring the ends together and hold them, and then pull until you find the centre point. Bend the centre point and clamp that into one of the crocodile clips. This stops the wire from flying all over the place, keeps it in position. Now we have to tin the ends of the copper wire. The way you do this is put a small blob of multi-core solder onto the soldering iron, and while it's molten, push the very end into the blob, and this will remove the enamel and leave the end of the copper wire tinned. It now requires you to place the tinned copper against the tiny gold flash, and the two will sweat together and give a small tug to make sure you've made a good connection. And then do the same with the other end. Always keep the iron clean to remove the old solder and the old flux. Pressing it together, a gentle tug. So now we have the two wires soldered to the white surface mount LED. Now take a piece of double-sided tape. This is about 1 centimetre square. You may choose to use a different size. Using some tweezers, remove one side of the protective film. This will reveal the adhesive on one side of the double-sided tape. Press it onto the tweezers, and this forms a convenient place to mount the surface mount LED. Release the vise, pull it off. You might find it sticks, that's because the accumulation of flux. Then place the LED into the centre of the double-sided tape and gently press it. It will stay there. Then take a small square of paper. I use printing paper. Fold it in half, fold it in half again, and very carefully, and this takes a bit of practice, cut off a tiny amount into at the centre, so that when you open it up, you have a tiny square hole. Place the square hole exactly over the LED and carefully press it on. Pull out the tweezers and then press down as hard as you can all round until you have trapped the LED and its cables between the paper and the double-sided tape. Then remove the excess paper. Finally, of course, if this is too large for your modelling, you can further reduce it by cutting it. Be very careful not to cut the wires. Right, now we actually have a microlight. Clamp it into the other crocodile clip to keep it in position, and moving to the other end, the loop of wire, cut off the end with side cutters which will reveal the two individual ends. These will need to be tinned so that you can connect them, and more importantly so we can test the LED to see if we haven't made any mistakes, and also to determine the polarity. Apply a blob of solder to the end, wait until the enamel breaks down, and then slowly move along the wire. If you go too fast, it won't work, and it's a hell of a job to get rid of the burnt enamel. Remove any dross, then do exactly the same to the other one. Oh, and I should also mention I should have turned the fan on, but for the purpose of the video, because it makes a noise, I'm leaving it off. But you're advised to use an extractor fan. Now, taking the test unit, the 9V PP3 battery, the 270 ohm resistor, touch it against the two ends to find out if it works. It doesn't work, so it must be round the other way. Press it against the connectors. The LED comes on, so we must now have the correct polarity. Keep a note of the red wire and the wire that it's attached to. Hold that, release it, tie a small knot in the end, and this will identify the positive end. If you can't see that dot, you can feel it. So the last thing is to mount the microlight, which is a little delicate, so I choose to mount it on a piece of card and to wind the wires around it to hold it in position. And there we have a finished microlight. So now you know how to make them. I hope you are encouraged to try to make them yourself, and I hope that I don't get any more requests to make them. I did enjoy making all the hundreds that I made, and I thank all the people that bought them from me, and I especially enjoyed seeing the pictures of the results of models illuminated with microlights. So there you go. Any more questions, please contact Branner Systems at www.branner.co.uk. Thank you very much.